Hello students, we are going to start today the last portion of the capacitor, that is charging and discharging of the capacitor. In order to understand charging and discharging of the capacitor, what is required, you are supposed to understand few basic things. What are those things? First thing you should know, I is equals to dq by dt, rate of flow of charge. Rate of flow of charge is called current. Second thing, you should understand that log x is equals to y to the base a means, this means e to the power y is equals to x. This is the first thing. This is the second thing. And you should also know the Ohm's law, potential difference V is equals to IR. This is the third thing. And some basic information of mathematics, that is your log m by n is equals to log m minus log n. And at the same time, you should know some basic integrations. What are the basic integration and differentiation. If you know these basic concepts, then you can understand charging and discharging of capacitors. This is also read as RC circuit. This is also read as growth and decay of charge. These are all the same things, and the study of this charging and discharging of the circuit is done under two headings. One, before steady state, and one, after steady state. After steady state, no current becomes zero, I becomes zero, so no resistor is required. I will discuss it in detail in the discussion of this matter. So first note it down, and then we will proceed to understand the details of the charging and discharging of capacitors. Now I am making first the growth, that is charging. First we are discussing the charging. In the charging process, there is a capacitor, and with this we have to make a resistor, and here is a battery, here is a switch, and potential difference is V. So capacitance is C. Capacitance is C of this capacitor. Initially, the charge on the plate, it is fully discharged. That means there is no charge on the plates of the capacitor. Initially, at T is equals to 0, charge on the plates of capacitor Q is equals to 0. Now this voltage V, it means that it is giving a potential difference. Now you see, if a battery is there in this way and this is giving a potential difference V, if we suppose here the potential to be 0, then here the potential will be V, so that this difference is your V. This is potential difference. This is potential difference. So this is your V. So right now the charge is 0. So here if we connect it in the initial stage, here we can take the potential difference, potential to be 0, and here also 0 in the beginning, and here V and here also V. So current is how much? So I is equals to potential difference by R, that is V minus 0 by R. So this is your I is equals to V by R. This is your maximum current. This is your maximum current, and at this moment the potential difference is 0. Potential difference is 0. Why? Between the plates of the capacitor. The moment we have switched it on, the charging process begins, and in this process of charging, this is positive charge, negative charge comes from here and goes in this way and reaches here. So at any instant, if here is plus Q, then here will be minus Q, because battery takes the electron from here and it makes it to go on this plate. So potential difference has been created between it. Now in this situation, if you will observe, we can find that here at any time t, charge on the plates of capacitor be Q. Suppose. So in this situation, what we will observe, here the potential difference is V. Now I will show you in the next diagram that how the situation changes. How when charge is developed here the potential difference will become Q by C. Here it is V, here it is Q by C. So I will tell you that thing in the next diagram. At any instant, the charge on the plates of capacitor, we have supposed it is plus Q, it is minus Q, capacitance is C. So here the potential, it is connected by the resistor, and the same battery is there, switch is there, and here you see it is connected V. So here the potential remains the V, and here the potential becomes Q by C. Why? Because Q is equals to CV. So V is equals to potential difference is equals to Q by C. Now you try to understand the current. Now if you will try to understand the current will be in this way, that current will be, we can take the current I is equals to potential difference V minus Q by C by R, and current naturally has decreased. So current has decreased. Here I decreased. So what we can write? We have to find the charging process. So we have to take that I can be written as dq by dt, that is equals to Vc minus Q by R. C. dq by dt. We have to calculate it. Now only we will have to do the integration. How? We will do in this way, and this current has decreased. So what we are getting? We are getting dq by Vc minus Q is equals to dt by Rc. Now we are getting the charge as the function of time. So next step is to integrate it. Initially time is 0, and then to T. Charge is 0 to Q. So if you will integrate, the integration will give you minus ln log Vc minus Q. Why minus log? 1 by x integration is log x and it is minus, so here it is minus, and the integration limit is from 0 to Q, that is equals to T by RC. Here 0 to Q. This can be written as ln Vc minus Q limit 0 to Q minus T by RC, and this is giving you ln log m minus n, log m by n, ln Vc minus Q by Vc is equals to minus T by RC. Now I have said that here the exponential is there, so it will go into the power. This can be written e to the power minus T by RC is equals to 1 minus Q by Vc. This can be written as Q by Vc 1 minus e to the power minus T by RC, or Q is equals to Vc into 1 minus e to the power minus T by RC. So this is our equation of growth of charge. Here Q is the function of T. Q is the function of T. At any time we can find the charge, and Vc maximum charge is equals to Q naught. This is the equation of growth of charge. So therefore Q is equals to Q naught 1 minus e to the power minus T by RC. Now it is important to understand one thing very carefully, that power does not have dimension. Power does not have dimension. So whatever is the dimension of T, RC will have the same dimension, so that it becomes dimensionless. So unit of RC is your second. And this is the question that is being asked in entrance examination many times, and this is called tau is equals to RC, and this is called time constant of RC circuit. This is called time constant of RC circuit. So in book you will find it is written in this way also, Q is equals to Q naught 1 minus e to the power minus T by tau. This is also the format in which you will get in the book. Now try to understand the meaning of time constant, but before that I would like to discuss the graph between Q and Q naught. Here you see when T is equals to 0, when T is equals to 0, this term becomes 0, this becomes 1, e to the power 0 1, and ultimately this term becomes 0. So charge is 0, initial charge is 0, that we have supposed. So Q is equals to 0, and when T is equals to infinity, then you try to understand. When T is equals to infinity, then 1 by infinity, So 1 by e to the power infinity, e is equals to 2.7, and then 1 by infinity 0, so q naught. So t is equals to infinity, q is equals to cv, that is q naught, that is maximum charge. This thing you all should understand very carefully. Now I will tell you about the graph of this charging circuit. If we want to plot the graph of the charging circuit, you will understand that here charge is there on y-axis and here time is there on x-axis. Initially, when time is 0, charge is 0. So this is the point. T is equals to 0, charge is 0, and maximum charge is q naught is equals to cv. This is the maximum charge line. And when t is equals to infinity, then maximum charge is reached. You see, this is the growth. It will be meeting at infinity. At infinite time it will be meeting. Also, you should understand one thing. This is exponential curve for the growth of charge, that it will take infinite time for complete charging. Therefore, what we have observed, if time is increasing, charge is increasing on the plates of capacitor. Time is increasing, charge is increasing on the plates of capacitor, and potential difference is also increasing. So if time is increasing, charge is increasing on the plates of capacitor, and the current I is decreasing. This is very important point during the charging. Now if we take t is equals to tau, if we take t is equals to tau, then you see what we are getting. Q is equals to q naught 1 minus e to the power minus 1. This is your q naught 1 minus 1 by e. This is your q naught 1 minus 1 by 2.7. As I told, E is equals to 2.7. So this will be give you q naught 1 minus 0.37, and this is give you 0.63 q naught. So q is equals to, this is the way we define the time constant. So if here the time constant I am taking here t is equals to tau, then you will be getting this value. This is your 0.63 q naught. 0.63 q naught, that is 63%. So this is your time constant. So time constant is that value of time in which the charge on the plate of capacitor becomes 63% of the maximum charge. So this is the time constant. Also, we can use this equation to find the current also, that how the current we can find. And what we have defined the current we have defined I is equals to dq by dt. So I is equals to dq by dt, and q is what? Q is your q naught. Here q is equals to q naught 1 minus e to the power minus t by RC. If we will differentiate it, we will get the value of current. So let us try to calculate the value of current. I is equals to dq by dt, that is q naught, which is maximum value of charge, d dt of q naught 1 minus e to the power minus t by RC. This can be written as d by dt of q naught minus q naught minus t by RC. This q naught is constant, so it will become 0. So my minus q naught d dt of e to the power minus t by RC. E to the power x differentiation will become e to the power x, but here RC is there, so we can write minus q naught e to the power minus t by RC into minus 1 by RC into minus 1 by RC. Q is equals to CV. Q is equals to CV. This minus minus will become plus. So CV by RC into e to the power minus t by RC. So CC will cancel. V by R e to the power minus t by RC. And this V by R is maximum current. So we can write I naught e to the power minus t by RC. So here we can get that current I is equals to I naught e to the power minus t by RC. In this way we are able to find the current also, that the current through the circuit is I is equals to I naught e to the power minus t by RC. This can be written also I is equals to I naught e to the power minus t by tau. So in this way we are getting current also as the function of time. Initially when t is equals to 0, what we are getting, I is equals to I naught, that is maximum. So initially the current is maximum, and when t is equals to tau, I is equals to I naught into 1 by E, and 1 by E is 0.37 I naught. So this is the way we can define the time constant, that current is becomes 37% of I naught. This is the time constant, time when. And also you can understand one more thing, if t is equals to infinity, then I is equals to 0. Why? This will become minus infinity, 1 by infinity, that is 0. So at infinite time, when the capacitor is fully charged, the current becomes 0. When the capacitor is fully charged, the current becomes 0. Now we will try to see the graph of this relation, that I is equals to I naught e to the power minus t by tau. Here see the graph, we are taking the time on x-axis and current on y-axis. So initially the current is maximum I naught, so it will have an exponential relation in this way. It will be going to infinity. Here it is I naught, and at this particular point t becomes equals to tau. This value becomes 0.37 I naught. This is the way the current is, and here the time constant, it is meeting at infinity. So it will take infinite time to make the current 0. Now the time constant has very high significance for any circuit. You should understand it very carefully, that time constant factor is very important, particularly in engineering branch, about discussion of the RC circuit. Every RC circuit has a fixed time time constant. You should understand this thing very carefully, that in the RC circuit the current becomes 0 when the current becomes 0, that state of capacitor is called steady state. That state is called steady state. So this is the way we have discussed the charging of the capacitors, that in capacitor initially the time increases, the charge increases and current decreases. This is the basic thing that we have discussed about the capacitor. You should understand that charging of capacitor is basically this one, that it is very small time, but charging equation, charge as a function of time and current as a function of time, we are discussing in this way. Now what I would like to tell you, that in charging and discharging, now we will see the discharge of the capacitor. Time constant, you have seen that it takes infinite time to fully charge the capacitor. For 99% charging the capacitor, it is easier, it will take a finite time, but it will take longer time to charge the capacitor from 99% to 99.9%, and it will take further more time to charge the capacitor from 99.9 to 99.99. It will be taking further more charge to charge the capacitor from 99.99 to 99.999. That means initially the charging process rate of charging is very high, and slowly it goes on decreasing, and it takes very large time. So infinite time it will take for charging the capacitor to full charge, and that is 100% charging is never possible. So if the time 99.9% charging time is T1 and 99.99% time is T2, naturally this T2 will be greater than T1. I mean to say this thing. And if you make 99.999 as T3, then T3 will be even greater than T2, greater than T1. This is the basic thing which I want to convey you by this one, because for 100% charging the time is going from moving towards the infinite one. So 100% charging of capacitor is never possible. From 99 to 9% we consider capacitor as the fully charged. In discharging process, what I will tell you, initially the capacitor is fully charged, so we will have to use some resistor in order to, it is fully charged. Here it is Q0 plus Q0, here it is minus Q0, potential difference V is equals to Q0 by C, this is R, and the capacitor is discharging. So when the capacitor is discharging, what I would like to tell you, in this process, initial current I will be V, this side 0, this side V, so V by R, that is Q0 by RC. This is your maximum current, at t is equals to 0, at any time, at time t is equals to t, suppose charge on the plates of capacitor is Q, at any time the charge has become Q. So in this situation, V by R, that is Q by CR. I is equals to, now charge is decreasing, so minus dq by dt, as the charge is decreasing, so minus dq by dt is equals to q by CR, or we can say minus dq by q is equals to dt by CR, or take it to this side. If we integrate, time is changing from 0 to t and charge is changing from q naught to q. Charge is changing from q naught, initially maximum charge, it has at time t it has become q. So if we integrate, we are getting ln current q 0 q naught to q is equals to minus t by CR, current. Now this can be written as q minus q naught. So this can be written as ln q by q naught is equals to minus t by CR, and this can be written as q is equals to q naught e to the power minus t by CR. Here you see, this equation is giving you the decay of charge. The decay of charge is represented by this equation, q is equals to q naught e to the power minus t by CR. So this equation represents the decay of charge. Decay of charge. This equation is representing your decay of charge. Note it down, then we will show you the graph. If you, CR is again your time constant, CR is your time constant, tau, time constant. Here you see, if we take t is equals to 0, e to the power 0, q is equals to q naught. What is this? This is initial value, and it is your maximum. So maximum is there, and when t is equals to infinity, then you see, then q is equals to, it is 1 by infinity, so infinity 0, q is equals to 0. That means fully discharged. So to become charge on the plates 0, time taken is infinite. That means fully discharged capacitor will take infinite time. If I take this thing on the graph, you will observe q is here, t is here, here is the maximum charge q naught, it is going to decrease in this exponential manner, you see, and it will meet at infinity. So here is the decrease, the charge is decreasing, and it will at time infinity it will become 0. Also, if t is equals to tau, then you will see that q is equals to q naught into 1 by e, because e to the power minus 1, so it is your 0.37 q naught. So at the time t is equals to tau, charge becomes 0.37 q naught. See, this is the way we define the time constant of the discharging circuit. That means discharging circuit time constant is that value in which the charge on the plates becomes 0.37% of the maximum charge on the plates of the capacitor. So this thing you should understand very carefully, and after this understanding we can find the current also. So how can we find the current? Let us try to understand that situation. Current I is equals to minus dq by dt, because charge is decreasing with time, so dq change in charge will be negative. That is your minus d dt of q naught e to the power minus t by RC. Sit, and this is giving you minus q naught e to the power minus t by RC into minus 1 by RC, and q is what? Q is your, so it is q naught by RC e to the power minus t by RC. This is the relation by which the current is decreasing with time. Also you should understand the relation. Initially the current is maximum at t is equals to 0, this is 0, 1, I is equals to q naught by RC, that is your maximum. I naught is q naught, I is equals to q naught by RC, that is maximum. So, and at t is equals to infinity, this infinity minus infinity 1 by infinity, so it is 1 by infinity, that is 0, I is equals to 0. To current to become 0, the same thing I am explaining here, that here if we take the I and if we take the t, the current will be decreasing in this manner. At infinity it will become, and here it is what? Here it is maximum. This is I naught. Initially the current is maximum. This is your I naught, that is q naught by RC. And also if t is equals to tau, then you will get I is equals to, this is your I naught into 1 by E, and 1 by E is how much? I naught into 1 by 2.7, that is 0.37 I naught. So if we take this value t is equals to tau, then here you will be getting 0.37 I naught. So what we have observed in this case, we have observed that as t is increasing, charge is decreasing and current is also decreasing. So whether it is the case of charging or discharging, the current always decreases, and this relation is basically exponential in nature. So you should understand this thing in a very careful manner, and this will help you in understanding the charging and discharging of the capacitor in a better way. 2-3 times practice and analyzing the graph will help you in building the concept in a better way. Thank you. Have a nice day.